Hello everyone! Today we will create a beautiful web application and we will publish it online. We will each build our own developer portfolio with Flask and SQLite, and we will load it into something called a virtual private server. Now, we will do it professionally using tools like Docker Stack and Swarm over a secure shell connection. Now, by the end of this video, each of us will have our website up and running live in a server that we've set up completely on our own, absolutely from scratch. And we will also learn how to update a live database without collapsing the entire website, resulting in zero downtime forever. So are you ready? Let's roll! Now, first things first, let's download some starter files. We will use a Flask website template that I've created in advance, and you can find it as Dev Portfolio Simplified on my GitHub. We will then click on code and we'll copy the HTTPS address of my repository. Then we will paste it inside our WSL terminal, and if you don't have one, you can easily install it with WSL-run, either from your PowerShell or from your command prompt. And then inside WSL, we will type git clone, followed by the URL we just copied. Then we will navigate to our project folder with cd or change directory, followed by dev portfolio simplified. And hopefully my head didn't block it. Now, to make sure all the files were properly downloaded, we will list all the files in the directory with ls. And beautiful. Now, if you're not familiar with the structure of a Flask website, here's a quick introduction, but I will share lots of detailed resources in the end of the video. For now, all you need to know is that main.py is in charge of running the application and handling requests. Our instance folder stores the database, and our templates folder stores the HTML web pages. And then lastly, we have the static folder that stores our images, our CSS style sheets, as well as our JavaScript interactions. Now, on our end, we have an additional Python file named initdb, or initialize database. And this is the only file that we will need to update for this project. The rest of the files are optional, but this one is an absolute must because it stores all the information of our app. But before we make any changes, let's quickly see how our website template looks like. For this, we will need a software platform named Docker, where Docker will help us isolate our website from the rest of the computer. And the idea is we will try to recreate on our system the exact same conditions that we will later have online on our remote virtual private server. So please make sure you download Docker Desktop if you don't have it already. And also make sure that your engine is running, given this green bar at the bottom. Additionally, navigate to your settings, and inside your general settings, make sure that you use the WSL-based engine, and also navigate to your resources, followed by WSL integration, and here also enable the integration with your default distribution. And great! Once we verified these two details, we can go back to WSL and we can type docker compose app. Now, once we see this output from Flask, we can navigate to our browser into our local host, either at port 80 or just simply localhost. It's exactly the same. And our beautiful web application already runs here. And what we have here is a quick portfolio, as well as our social media information. And then below it, we have the list of our best GitHub projects. And then at the very bottom, we have a list of skills that we've used for these projects. So all the programming languages, all the tools, all the libraries and software that were used here. And it gives our employers a very nice summary. And perfect. So let's go ahead and fill all these placeholders with our actual information. For this, we will open init database, and we immediately see all our placeholders inside it. And the idea is, if we ever need to change anything in our site, we only change it here, and then it automatically updates everywhere else. So for example, let's start filling in our information. Now, in my case, my email is mail2maria@pythonsimplified.org. My YouTube handle is, of course, Python Simplified. and so on and so on. Now, in terms of my projects, the first one, let's say, is an AI voice chat application. And let's say that it has the description of text to speech voice assistant with Quen. Then we will copy the URL of my repository that I've prepared in advance. We will, of course, paste it inside of the placeholder. And then in my case, I'm going to leave the thumbnail as is because a voice chat PNG is a perfect match to my project. Now, on your end, let's fix this typo. Now, on your end, you will probably need different kinds of thumbnails. In that case, just navigate to a site like FreePic, then search for something like fancy database, go for the photo implementation, and then when you find your favorite picture, let's say this one, just click it, click on crop, and then choose a costume crop size of 800 pixels by 275 pixels, which is the exact size of our thumbnails. Then we'll confirm it. Now, if it's a bit too small for your taste, you can of course play with the sizes. So let's double our values here with 1600 and 550. Let's confirm it and it will work as well. Then we'll go ahead and export it into a PNG image and we'll then paste it inside our project folder at static assets thumbnails. Then we'll of course change the name to fancy database and boom, you got a new thumbnail. Now, in terms of the social media icons, I've stored them inside assets icons, and you will find more social media icons than I should have included. You have here Facebook, Instagram, and TikTok, which you will not see in the app. So if you'd like to include them as well, or instead, please feel free to do so. I already arranged everything for you. And great, so let me quickly fill in the rest of the details off camera, and I'll be back shortly. Now, once we're done filling our details, this file will convert them into an SQLite database. And this database will have 4 different tables. The first one is socials, the second one is projects, then skills, and then profile, which is a perfect match to our Python data structures right here above. Yay! Now let's quickly save everything. Let's navigate to our browser where as soon as we hit refresh, we are no longer dealing with a template, but with an actual professional developer portfolio. Now on my end, I've added 6 projects, but on your end, please add as many or as little as you'd like. And same goes for the skills. This is just to demonstrate what can be done. Now, another thing you can customize is the styling of this website. For this, we will navigate to our static directory, followed by style CSS. And in this file, we store all the colors, the fonts, the location, and sizes of elements. So for example, if we'd like to customize this blue portion of our gradient background, and we would like to change it to some kind of pink, let's say DE00C0. Let's save this file. Let's go back to our browser. Let's refresh it. And boom, our gradient now has pink instead of the blue. Now, if you also think that the size of my fonts is a bit too big, we can go back to our style sheet and we can specify the font size attribute, setting it to 0.75 EM. Now, once we save this file and we refresh it, our text is now 25% smaller all over the place. Additionally, if you'd like to add some animations to your website, for example, this title that keeps moving at the very top of our browser, the way to do so is to navigate to your script.js file, also inside your static directory. And there you go, here's the script for our title animation. And while JavaScript and CSS is beyond the scope of this video, I have so many tutorials that can help you with that. I'm just keeping them for the very end because I think most of you already know how to do it. Great, so let's say we are happy with our website and we are ready to publish it. What do we do next? Well, if we quickly look inside our terminal, we see this red warning message from Flask saying that this is a development server. Do not use it for production deployment. But production deployment is exactly what we're trying to achieve. So how are we supposed to solve it? Now, what this warning means is that if we open our main Python file and we scroll to the very bottom, it tells us that this app.run command is only suitable when we are still working on our application, when we are developing it. But as soon as we're done and we're ready to share it with the world, this should not be our entry point, okay? So in our case, we will use a special production server named Green Unicorn. And we will do so by opening our Docker file. We'll just drag it right over here. And then right below our Flask installation, we will run pip install g unicorn, or Ganicorn, or Green Unicorn, or whatever. And now, since the usual entry point we use for a Flask application, which is Python 3 main.py, since this command is not gonna work, let's quickly get rid of it, and let's replace it with another set of arguments. Now, the first argument is Ganicorn, the name of our server. The second argument is a flag named --bind, to which we will assign another argument, the value of bind, which is a combination of our host 0.0.0.0 followed by a colon and then the port in which our Flask application runs. In our case, 5000. Now, if you're curious where these numbers are coming from, just navigate to your main Python file and you see your host right inside the run method as well as your port. And it's a copy and paste situation. Now, back inside our entry point, we will need another argument, one that maps the name of our file, main, to the variable in which we saved our Flask object, in our case, app. Now, a quick tip to speed up the performance of your server is to add an additional argument right in front of bind, in our case, --workers, and assign it to an integer like 5, where 5 represents the number of tasks or requests that can be processed at the same time by the server. So if we leave it at 1 or just leave it blank, our server will only process one request at a time. So we will have this giant bottleneck. So if you want to boost the performance, then 5 is a very good solution. Okay, now let's save this file. Finally, let's navigate to our terminal. And because we have updated our Docker file, which basically builds our environment, we will need to collapse our running container with Ctrl+C. We will then need to rebuild our image with Docker compose build. And then finally, we will run our container again with Docker compose up. And beautiful, when we look in our terminal, we no longer see a red warning and everything works as expected. And now if we navigate back to our browser and refresh the web page, nothing changes. Everything looks exactly the same, which is perfect. The only difference is, instead of dealing with a development server, we are now dealing with a proper production-ready server. But there's just one problem. If we are now trying to revise our dataset, for example, let's go back to our init.db file and let's quickly get rid of some of our projects. There you go. Let's get rid of 2 of them. Let's save everything. Let's go back to our browser. Let's refresh it and let's see the verdict. Nothing changes at all. Our database doesn't automatically update anymore. In order to update it, we need to go back to our terminal. We will need to collapse our application. We don't really need to rebuild the container, but we will still need to rerun our container once again with Docker compose app. And now, if we refresh the page, our changes were finally applied. But this is actually a very big problem, because if our website was live now and we wanted to add just a tiny little project to our portfolio, we would need to take down the entire website for all the changes to take place. And even though we would probably take it down just for a few seconds, this is obviously not the professional way of doing so. So instead, let's use something called Docker Swarm to separate our web GUI from our database and make them run independently. For this, we will open our Docker compose file and let's have a quick look inside, where we see 2 different services. The first one is called Web and the second one is called Updater. Now, while our web service is occupying port 80, which is actually the only port that allows us to access our app simply by typing localhost without specifying localhost in the port of 80. Now, We can of course do that, but as soon as we hit enter, we are back to the original location of localhost. So this is a very nice shortcut. Now, on the other hand, our updater doesn't occupy a port, but instead, it simply remains alive in the most minimal way possible. Now, so far, we've been running these two services for local development, and it was perfect. But when it comes to production, we usually switch the way they are deployed. For this, we will navigate to our terminal, and let's close everything behind the terminal, and let's collapse our application with Ctrl-C. And then we'll activate a special Docker mode named Swarm with Docker Swarm init. And then in Swarm mode, we can say Docker stack deploy, followed by the path to our Docker compose file. In my case, -c, followed by docker-compose.yml. Additionally, we will choose a name for the stack, in my case, my-portfolio. Let's give it a run, and oh no, we get an error because an image reference must be provided. So let's have another look in our compose file. And in our case, we're not really referencing an image, but instead we are building a new one from the context of our Docker file. So we are executing all these instructions instead of just referencing an existing image. Now, usually it works like a charm, and it worked so far. But in Swarm mode, we need to pre-build an image, and then we just specify it for each of our services. So let's do it. Let's go back to our terminal, and then we will build an image from our existing Docker file with docker build-t, followed by the name of the image, in my case, my-portfolio, and followed by the location of our Docker file, in my case, the current directory or dot. Let's run it, and beautiful. My portfolio image is ready. So let's quickly copy the name, and then back in our compose file, instead of a build in context, we will specify an image, and we will assign it to my portfolio in the tag of latest. And we will do the same. And we'll do the same for our updater service, replacing build and context as well. Now let's save it, and let's try to deploy our stack once again. And this time it should work, okay? So at the very bottom, we will pull our docker stack deploy command, and let's give it a run. And beautiful. We have successfully created a network of services. The first one is called My Portfolio Updater, and the second one is called My Portfolio Web. And even though our terminal is not occupied, these services are currently running. How do we know that? Well, if we type docker ps to display all the active containers, we see both our services here. There you go. Here's My Portfolio Web, and here's My Portfolio Updater. In addition, if we navigate to our local host and we refresh the page, everything still works. Incredible. But the only difference is that now, if we would like to update our database, we'll just quickly navigate to init-database.py. We will get rid of two of our projects just to test it. Okay, we will save this file, and then we can say back in our terminal, okay, actually, let's leave our application on just so we can make sure that it doesn't collapse. That's our main goal here. To update our database, all we need to type is docker exec as in execute, followed by the container ID of our updater. Okay, it's a bit difficult to read, but we need this ID over here, which is 387B and so on. If I make my terminal text a bit smaller, it will make more sense. Okay, there you go. So we just copy the container ID of our updater service and we paste it following exec. And then lastly, we need to specify the Python command we would like to run, in my case, Python 3, followed by the path to our init database file as it is stored in the container, okay? Not on our system, on the container. So in my case, that will be /app/init_db.py. Now, how come, you must be asking, app? Well, if we go back to our Docker file, we will see that our working directory inside the container is at /app. If it is something else on your end, specify it instead. What it is not referring to is the app.run of our main.py file. It has nothing to do with it. It just happens to be that this variable name is matching this folder name. What it really represents is the working directory, okay? I hope it's clear. Now, let's pull our website once again. We will verify it works as expected. And now, let's execute this command without typos. Okay, init.db. Let's give it a run. And boom, our database tables were dropped and repopulated while our website is still on. And then once we hit refresh, our changes are being updated like a charm, and we had zero downtime in between. And perfect. We are officially ready to publish this app on a remote, virtual, private server. Let's do it. Now, on my end, I'm using a web hosting provider named Hostinger, and I even got you some coupon codes in case you'd like to follow along. So let's quickly navigate to hostinger.com/Python simplified. And what we're going to do here is create something called a virtual private server, where Hostinger takes a very big and powerful computer and then it splits it into smaller sections that can act independently. And then each of these sections is like its own computer. So by getting a VPS, you are getting one of these sections just for yourself and for your app. And that's exactly what we'll do. So let's start with the fun part, which is choosing the size of server that best suits our needs. Now, I have a very detailed tutorial about it. You can check out my Introduction to Cloud Computing, where I explain exactly what this vCPU means and how much RAM you need and so on and so on. But the rule of thumb is, if your app is relatively simple, just like my portfolio, and if you're not expecting lots and lots of traffic, then the default plan will do just fine. If your website is more complex or very, very popular, then maybe go for the more advanced plans. But on my end, I will choose the KVM2 plan, so let's hit this Choose Plan button. Now, in my case, I need this server for a period of 12 months, which is more than enough time to find the job, okay? Now, before we forget, let's also enter our coupon code right over here, and surprise, surprise, it's Python simplified. Let's hit apply, and beautiful, we just got a 10% discount on our purchase. And by doing so, you are also supporting this channel. So this is not just the discount. Now, once we are done with that, we will then choose a location where most of our audience lives. In my case, United States or North America. And then finally, we will choose an operating system for our server, in my case, Ubuntu, because it's the exact same operating system as my WSL. Now let's hit confirm and let's continue. Now, let me quickly fill in my details and purchase it off camera, and I will see you shortly. Now, once we are done with the purchase, we get a malware scanner for free. So let's hit continue. And now let's choose a root password for our server. Now, we will not type this password very often, so please feel free to make it as complex and as long as you'd like. So it's provided here. And once we are done, let's hit continue. And finally, let's finish our setup. And it may take a few minutes to set it up, so just go get some coffee or run a quick errand, and I'll see you soon. Now, once our server is ready, we will navigate to the VPS dashboard, and from here, we will navigate to settings, followed by SSH keys, as in secure shell, and we'll of course add a new one. Now, what we're doing here is establishing a connection between our computer and our remote server on Hostinger, and we do so using something called public keys. Now, lucky for us, all the instructions we need are here on the right. So let's quickly copy this key generation command and let's paste it inside our terminal. And here we will of course replace this example email with our actual email. Let's hit enter. And then we will hit enter once again to save our key at the default location. Okay, let's do it. And now let's select a password that we will type very, very often. So make sure it is one that you remember and one that doesn't frustrate you. Okay, let's do it. And congratulations, we have successfully generated a public key and it is now saved, at least in my case, in Home Maria SSH. So let's navigate there. And here you will find two files. The first one is a private key, which is an absolute secret. Do not share it with anyone. And right below it, we will find our public key, which is the exact key that we need to share. And this file has the extension of .pub. Great, so let's open this file. Let's copy its entire content and let's paste it back inside Hostinger. Additionally, we will specify the name of the system where our public key is saved. In my case, Rogue. Now let's save it. And beautiful. We can now officially communicate with Hostinger directly from our terminal. For this, we will navigate to our overview and we'll copy this root access command, which basically consists of our username, root, and the IP address of our server. So let's copy it and let's paste it in our terminal. At the very bottom, there you go. Let's hit enter. Let's confirm that we are communicating with a trusted source by typing yes. And let's provide the password which is generated. And beautiful, we are now officially connected to our server. How do we know that? Well, first, we see this welcome to Ubuntu 24.4 message. And if we list all the files in the current directory with ls, we will get nothing in return because we have just created this server, so it is obviously empty. So let's quickly fix it by installing all the requirements and dependencies that we will need. Now first, let's make sure our package index is up to date, and we will do so with apt update. And we see that there is a single package that can be upgraded. So let's quickly upgrade it with apt upgrade-y. Then we can go ahead and install Docker with apt install-y followed by docker.io. Then we will start our Docker engine with systemctl, as in system control, followed by start Docker. And to make sure it automatically starts every single time, we will type systemctl enable Docker. Beautiful. We can now install Docker Compose with apt install-y docker-compose. Great. So we are officially done with setting up our server and installing all the dependencies. And now it is time to copy all the files from our local project folder into our remote server. And there are several ways to do it, but the most beginner-friendly way is probably just opening a new WSL terminal. We will call it Terminal B, and let me quickly enlarge it. Now, the first thing we do in Terminal B is navigate to our project folder with cd dev portfolio simplified, where our entire website lives. Now, to copy all these files from our system into the remote server, we will type scp, as in secure copy, followed by -r, as in copy all the files and all the folders. Then we will specify an asterisk, which means copy the entire content of our dev portfolio simplified folder. And then we will specify root at the IP address of our server. So let's quickly copy it from Hostinger. And this is this number right over here. Let's paste it back in our terminal. And then with a colon, we will specify the location on the server where we would like to save our files. In my case, I'd like to save them at the root directory or wavy symbol /. Let's give it a run. And perfect. All our project files were successfully copied. So how do we know that for sure? Well, if we navigate back to Terminal A, where we have our SSH connection, and if we try to list the content of our server once again with ls, we will now see all our project files inside. Yay! And from here, we'll just repeat the same steps as earlier, where the first one is building an image with docker build-t, followed by the name of the image, my portfolio, followed by the location of our Docker file or dot. Now, once my portfolio latest was generated, we can then switch to swarm mode with docker swarm init. And now we can go ahead and deploy our Docker step with docker stack deploy, followed by -c, and then the path of our compose file, docker-compose yml, and we'll call this stack my portfolio as well. And beautiful. So now when both our web and updater services are running, we can just navigate to our browser. We can copy the IP address of our server, and then in a new tab, we will paste it. And boom, our developer portfolio is officially live. Bravo! Now on your end, if you're getting some kind of an error, maybe try waiting a minute or two for all the changes to take place. It sometimes takes time to update. But if waiting doesn't help, maybe try clicking on this Reboot VPS button. I didn't have to do it on my end, but I'm mentioning that it's here just in case. Now let's say we are super happy with our portfolio and we are ready to share it with the world. But we forgot to add the most important project in the list, the developer portfolio itself. So let's quickly navigate to our init database on our local system, and let's copy one of these existing dictionaries, and we'll slightly adjust it. Now let's quickly save this file, hopefully no typos, and then back in our terminal, our local system terminal or terminal B, and actually let me pull the website here just so we can see that nothing collapses when we're making these changes. Okay, so inside terminal B, instead of copying all the files from the current directory, let's only copy init database. We will do so by pulling our recent command and then replacing -r and asterisk with init_database.py. Now, since we'd like to store it instead of the existing file, let's also mention it explicitly at the very end, adding it as init_database.py. Beautiful. Let's give it a run. And awesome, our file was successfully copied. So now we can switch back to terminal A. We will then pull the container ID of our updater with docker ps. And there you go, we have our my portfolio updater, and it has the container ID of AC2 blah blah blah. Let's just copy it. And then right below, we will type docker exec, followed by the container ID, followed by the command we would like to execute, or python 3/app/init database.py. And beautiful, our tables were dropped and repopulated while our website is still live. So now, if we go ahead and we refresh the page, we see that we have a brand new project in our portfolio, which is our dev portfolio website. And after a few more seconds of wait, our thumbnail is here as well. Amazing. Now, if you'd like to create a different website, but you're not sure how, here's a list of resources that you may find helpful. Now, the first one is a simple Hello World application with Flask. The second one is a basic introduction to SQLite, but unlike myself, please don't forget the connection.commit command at the very end. This is my oopsie, but on your end, please fix it. Now, the third one is an advanced Flask application with SQLite, with JavaScript, with CSS, with HTML, and all that jazz. And then finally, we have an introduction to Docker, in case you find some of these commands confusing. So yeah, hopefully you will find these resources helpful. And if you come up with something really cool, please make sure to share it in the comments below with myself and with the world. And thank you so much for watching. If you found this video helpful, please share it with the world. And don't forget to leave it a huge thumbs up and all kinds of comments. Now, if you'd like to see more videos of this kind, you can always subscribe to my channel and turn on the notification bell. I'll see you soon in an awesome tutorial. So in the meanwhile, bye-bye!